Welcome to the visitor pattern, one of the most clever and admittedly one of the trickiest patterns in the Gang of Four catalog. By the end of this video you will understand what problem it solves, how it uses a technique called double dispatch to work its magic, and exactly when reaching for it is the right call versus when it will only make your life harder. Imagine you are building a compiler. You have a small, stable set of node types: number node, binary op node, variable node. Now your team needs to add a pretty printer, then a type checker, then a code generator. Each time, you crack open every node class and add another method. After a few rounds of this, each class is a tangled mess of unrelated concerns, and every new feature is a risky edit to code that was already working. Think about a building inspection. The building, the object structure, never changes. What changes is who walks through it and what they look for. An electrical inspector checks wiring. A fire marshal checks exits. A tax assessor estimates value. Each inspector carries their own logic and applies it to every room they enter. The visitor pattern works exactly the same way. You send a visitor object through a fixed structure, and it does its specialized work at each stop. The visitor pattern defines two parallel hierarchies. On one side you have your elements, the stable objects that form the structure. Each element declares a single method called accept that takes a visitor. On the other side you have visitors, one per operation, each of which declares a separate visit method for every concrete element type. The client simply hands a visitor to the root element, and the pattern takes care of routing from there. Let us trace through this code. The EXPR visitor interface declares one visit method per concrete element, visit number and visit binary UP. Both element classes implement accept by calling the matching visit method on the visitor, passing themselves as the argument. The eval visitor then implements the actual evaluation logic. Visit number simply returns the stored value, while visit binary op recursively calls accept on its left and right children, passing itself along, then combines the results. The client builds the tree for 3 plus 4 times 2, and calls accept once on the root. From that single call, the pattern fans out through the entire tree automatically, and we get 14. The secret ingredient is called double dispatch. A normal method call dispatches on one receiver, the object you call it on. Here we need to dispatch on two types simultaneously, the element type and the visitor type. The first dispatch happens when the client calls accept on the element that picks the concrete element class. The second dispatch happens inside accept when the element calls visitX on the visitor that picks the concrete visitor and therefore the operation. Together, two ordinary virtual calls achieve what most languages cannot do in a single call. The payoff is that adding a brand new operation, say a type checker, means writing one new class and touching nothing else. The cost is the mirror image. Adding a new element type forces you to update every existing visitor. The visitor pattern shines when your class hierarchy is locked down and you keep adding new things to do with it. Compilers, document processors, and game engines all fit this profile well. But if the hierarchy itself is a moving target, visitor becomes a liability. Every new node type forces you to edit every visitor class, which is the exact kind of shotgun surgery the pattern was meant to eliminate in the other direction. If you only have one or two operations, or your elements need to protect private internals, a simple method on each class, or even a plain switch statement, will serve you far better. To sum up, the visitor pattern lets you define new operations over a class hierarchy without modifying any of its classes. It achieves this through double dispatch. The element picks itself, then delegates to the visitor which picks the operation. That makes adding operations cheap and safe, but it inverts when things get expensive. A new element type ripples through every visitor you have ever written. When your structure is stable and your operations keep growing, visitor is an elegant solution. When the structure itself is in flux, reach for something simpler.